Hi, you nine. No one's turned up to my Zoom yet, so I'll do a video just in case. This should be stuff that you already know. We're doing area of quadrilaterals today. So you just have to go over your basic area formulas. So the first one here is obviously, this is what I would have done on the video. This is obviously a square. Oh, that's a bit fat, isn't it? And hopefully you remember that the area of a square is side times side, or length times length. So you could say it's either side squared or the length squared. Let me just reduce that thickness, it's a bit fat. There we go. And then this one, hopefully you also know, is a rectangle. Okay, and a rectangle is exactly the same. Length times the width, sometimes known as the breadth. So the area of a rectangle is length times width, or sometimes it's written as length times breadth. Okay, and then we've got triangles. Now there are 3 different types of triangles. I just want to make sure you know that they are pretty much all the same. So here's one, here's another, and here's our old favourite. So I'll start with our favourite, and hopefully you all know that the base is here and the height is here. And because a triangle, especially this one, looks like half of a rectangle, you know that the area formula is half times the base times the height. That's our basic triangle formula. Now these two up here are the same thing, whereas this one, it's obvious the base is here and the height is actually inside. Now I want you to take note, the height and the base are always at right angles to one another. So this would also be half times the base times the height. Sometimes they say BH over 2, all means the same thing, doesn't it? And the last one that some people aren't aware of, just in case, sometimes you've got triangles where the perpendicular, so it's got to be at right angles to the base, can't be inside the triangle, and they might give this section as being the base. So since the height has to be at right angles, it's actually outside of the triangle, and the height would be out here. So just be aware that you can have triangles like that. Also, all just half base times height. Now I've made some videos for those of you who'd like to watch them, just in case, for example, you don't know how they came up with the trapezium formula, because that is a pretty hard formula. So my first one here, hopefully you all know this one, is a good old parallelogram. Should have done this in year 8. Just in case, let's go over it. Now a parallelogram, if you took that triangle and put it over here, it would just make a rectangle, wouldn't it? So all we do is we multiply this one here, the base, by this one here, which would be the height of the rectangle. So the parallelogram formula is just area equals the base times the height, and just like my triangles, I'll do it in red so it stands out, the height and the base must form a right angle. So normally in a picture you'll see the height here, okay, and with a little red, with a little, what's it called, right angle sign. That's it. Okay, try the next one, get back to my green. Alright, so next we have, hopefully you know this is I'll write it over here a bit more so I can do some cutouts. This is a rhombus. Again, I've got a video down the bottom just in case you're not sure where that formula came from. So what we do in a rhombus is we cut it in half like it is just there, okay, and then we might also cut one of the triangles down that way. And then what we try and do is we try and create a rectangle. So what happens is I draw half of the big triangle this way, and then I put this half here, and I put this half here. So what happens is we get a rectangle. Okay, so really what we're trying to say is, now, if this long bit here, I'll do it in red, this long bit here is the base of this triangle, then that's the long diagonal, if you wish, which we sometimes call X. And then this one here, I'll do in purple, is half of the other diagonal, which really is represented here by the height, and we normally call that Y, okay, which is a half of the other diagonal. So in a rhombus, okay, if we've changed it into a rectangle, we're going to be doing the length times the width or the breadth, aren't we? So we're going to be doing the X times half of the Y. So in other words, what you're actually doing, I'll do this in green, is you're doing area becomes half of one diagonal times by the whole length of the other diagonal. Now you'll find in Australia we say half times X times Y, and it doesn't really matter which diagonal you're halving, so that's why the Y is not first and the X is second, like I did in my diagram. In America, they just pretty much use half D times D, okay? So, but that's what we're doing, and that's where that particular one comes from. And now this one here, hopefully you know, this is a trapezium. And again, I've put a video down there just in case you can't remember, or because I couldn't remember, quite frankly. You can't remember how to find the area of a trapezium, but the lady from Let's Do Maths did a really good one. And what she did was she cuts the trapezium on a diagonal like this. So that makes this height the same for both triangles. So I believe she puts it on the outside here. So what we do is we use this one as the base of this triangle number 1, and we use this as the base of this triangle number 2, and the height is always the same. So I believe she called this particular base A, and she called this particular base B. So if I move it over here, this triangle over here looks like this. Something like that, okay? So, and I'll do it in red. So the base is this one, and the height is this one, okay? And we're going to call this is the base, but for safety's sake, we're going to call it an A. So if you remember, how do you work out the area of a triangle? You go half times the base, which in this case is A, times the height, don't you? So a bit of algebra, we get a half AH, or if you like, I think she puts it AH over 2. Doesn't really matter, okay? They both mean the same thing in algebra. And then this second triangle here looks like this. Let me see if I can remember it. Right, okay. Looks something like this. All right, where the base is here again, and the height, remember, was outside. All right, so what she's done there is she's made the base letter B in this case. So if we do the triangle formula again, it's a half times the base B times the height, or BH over 2, or half BH. Okay, so what we're doing there is now we've got to add those two together. So, add together. So I've got to go AH over 2 plus BH over 2. I'm going to do it like a fraction. You can do this many different ways. Okay, so that means we're going to get, now since both fractions are over 2, what that means is I can add the tops. So that's what I'm going to do. I'm going to go AH plus BH and put them all over 2. All right, and if you watch her video, she does this as well. Okay, and now I'm going to do what's called factorising. Can't remember if we've done this yet, but I'm going to go over it. So if you look at the top part of the fraction, do you notice there is the same letter in both of the terms AH and BH? Hopefully, pardon me, you said yes, miss. So I'm going to take the H out of both of the AH and the BH, and I end up with this formula. And this is the trapezium formula. Okay? Now there are plenty of examples in your exercise today, and I'd like you to practice using all of those formulas today. I don't think I've set you any maths online today, but if you would like maths online, just let me know. I don't think anyone's turned up yet. Everyone must still be asleep, unfortunately. Now, if you are having any problems getting onto Zoom, can you follow the instructions at the top of today's box and see? I think they've done an update, or you may not have updated in a while, and it's not always working. Now, the next thing that I wanted to go over with you today was changing units. Now, most of you know how to change units if it's in length. So how many metres in a kilometre? Hopefully you said there's 1,000, miss. So when you change kilometres to metres, follow the arrow. You times by 1,000. If you go from metres to kilometres, you divide by 1,000. You might want to write this one in your book if you can't remember it. How many centimetres in a metre? Hopefully said there's 100, miss. So metres to centimetres, follow the arrow. You times by 100. Centimetres to metres, you divide by 100. And then the next one, centimetres to millimetres. How many millimetres in a centimetre? Well, there are 10. So if you're going from centimetres to millimetres, you times by 10. And if you're going the other way, you divide. Now don't forget, you could also do this if you wanted. Metres to millimetres times 100 times 10 actually gives you times 1,000. And then millimetres to metres is divide by 1,000. Now when you're changing area units, the thing that you have on an area unit that's different to length is that funny looking thing there, isn't it? It's a squared. So the easiest way to remember how to convert area units, how to convert area units, because most of you know how to do length. It's not the same as length, okay? The difference is this. Because area units have a squared on them, then every single number in this jumpy diagram gets a squared. Notice I'm putting squared on everything. Squared means 100 times 100, 1,000 times 1,000. If we're dividing, it means we divide by 100 divided by 100. Okay, and this one means divided by 10 twice. All right, so be aware that that's what you're doing on your calculator. So to change my area units from this one, I have a look to see what's my units there. It's millimetres squared. My units here is centimetres squared. I'll change my colour so I can see it. So I start at millimetres and I follow my arrow to centimetres. So I'm going to do this one here. On my arrow, it tells me to divide by 10 squared, which means divide by 10, divide by 10, okay? If I do that on my calculator, or I can do it in my head really, divide by 10 means every time I divide by any number with a 0 in it, I jump one place. So if I divide by 10 twice, I'm jumping 2 places. So my answer becomes 8.59 centimetres squared. So watch out. It's not divide by 10 because there's 10 millimetres in a centimetre. Because it's area, you must remember to incorporate that squared. And last one, 2.37 metres squared equals so many centimetres squared. I'm going to do this one in blue. Oh, it's already in blue. Don't do it in blue, miss. I'll do it in purple. Okay, so we're starting at metres and we go to centimetres. So I'm starting at metres and going to centimetres. So I'm following this arrow. It tells me to times by 100 squared. So that's what I'm going to write under here. So that means I am timesing by 100, timesing by 100. Notice there are 4 zeros. So if you want to do the jumping method, you can use your calculator. There's no problems. I'm going to jump 4 spaces that way. So when I divide, I jump that way. When I times, I jump that way. Okay? That gives me 2 spaces, which I need to put zeros in. Don't write the dot. 2, 3, 7, 0, 0. Okay, that's all I wanted to go over with you today. So good luck. Please have a go at the exercise, and I'll be emailing people, please, if you're not getting your work done, darlings. Bye.